So, new title, focusing on the years to decades time frame. So, some of you might have seen this prediction. So in the 1930s, and I'll try not to wander too much so the people on Zoom can see me. In the 1930s, economist John Maynard Keynes made a now famous prediction. He said that by 2030, technology will have developed to a point where humans only need to work 15 hours a week. And he said that the only purpose of the 15-hour work week would be to keep us from getting bored. Has anyone seen this prediction? Now, there's always maybe one or two, but yeah, supposedly it's famous. As it turns out, we're not going to reach this point by 2030 because we actually already reached it in 1970, at least in Australia and the US, and then European and UK countries followed soon after. And estimates today suggest that in order to meet the agricultural and manufacturing needs of society, so the work that really needs to be done in order for society to function, we would all just need to work about 8 hours a week. Wouldn't that be nice? So this kind of begs a really important question, which is when we have technological advance at this scale, what do we want to do with it? Okay, so ideally we do one of two things. We either use it to enjoy more leisure time, so we automate work so that we can achieve the same level of economic output while working less, or we can produce more. So we can make more stuff, and hopefully as a result of making more stuff, we can enjoy collectively greater prosperity. So how are we doing with those? So are we working less? So for a while, we were. So during the workers' rights movements of the late 1800s and early 1900s, there was a steady, continual decline in the hours people worked per week, which stopped around the 1940s at the 5-day, 40-hour work week that we all know today. Since then, it's really been zero change. It's just a flat line, and this graph only goes till 2000, but since then, it's been the same flat line, and it's actually even increased in some countries. And it's not as if technological advancement stopped at the 1940s, right? If anything, it's accelerated since then. So overwhelmingly, then we've opted against giving ourselves more leisure time and sort of doubled down on producing stuff. But that's fine, right? There's nothing wrong with that. The idea is we produce more stuff, and then collectively we enjoy more prosperity as a society, right? Well, if you're in the top 5% of income earners, you will have enjoyed more prosperity. If you're in the top 20%, you might have enjoyed a little more prosperity, but for the vast majority of us, this is not the case. The prosperity is not equally distributed amongst everyone in the population. So we're kind of 0 for 2. We're not enjoying more leisure time. We're not enjoying more prosperity, even though we have the technology, or have had the technology to do so for half a century. And in response to this, and in response to other things as well, there's been increasing calls for a large-scale transition to the 4-day work week. And there's some preliminary evidence that cutting people's hours, but not cutting their pay, can enhance well-being while maintaining productivity. And so this is progress, but there's a problem with this approach in that it's completely atheoretical. There's no theory behind this. We're basically just comparing one arbitrary alternative, one arbitrary policy to another arbitrary policy. And because it's completely atheoretical, there's limits about the inferences we can draw. So we can only draw inferences on policies that we actually test. So we don't know, for example, so we know maybe that 4 days might be better than 5 days, but we don't know whether, say, 3.5 days is better than 4 days, or maybe 4.2 is where the sweet spot is. So an alternative approach is to kind of use this sort of ground-up approach, which is a data-driven approach where we use the available data to build a model that can estimate more directly where this sort of sweet spot is. So we're not starting from an arbitrary reference value, so 5 days or 4 days. We're just using the data to see where that sweet spot is. So in this case, the sweet spot being the optimal number of work hours for well-being. So what do we know about this relationship so far? Well, we know that the optimal number of work hours is not 0. as some economic theory might suggest. So as organizational psychologists, we know that work is really important. It gives us intrinsic motivation. There's intrinsic value to it. It gives us a sense of mastery, gives us a sense of social connection. All of these things are critical for well-being. But there's actually some interesting research that suggests that maybe we only need about 8 hours a week to deliver these well-being benefits. So we don't necessarily need to work 40 hours a week to have these well-being effects. We also know that too much work is bad. There are tipping points where overwork can start to have detrimental effects on well-being. But we know that the relationship between work hours and well-being is really hard to study. A lot of this draws on cross-sectional designs, which are really hard to draw inferences from. And there have been calls for more rigorous longitudinal studies in this area. So as it turns out, though, we have running in Australia, not the longest, but one of the biggest and one of the longest running longitudinal studies that examines the relationship between work hours and well-being. It's the HILDA survey. So some of you might have come across this, the Household Income, Labor and Dynamics, the Household Income and Labor Dynamics Survey in Australia. It's a representative survey that's been running since 2001. On average, it assesses over 17,000 Australians each year. And of course, the survey doesn't just measure work hours and well-being, it measures all kinds of things. But for this analysis, what we're going to be interested in is the mental health measure from the SF-36, which is our measure of our well-being, and the hours per week usually worked, which is in the survey. And then also interesting that they included in the survey the hours per week that people prefer to work. And so all up, we analyzed data from over 132,000 observations from over 18,000 employed participants. And I'm not sure if I mentioned, but it's a yearly survey. So we've got 20 years every year from 2001. So earlier in the year, I ran 2 analyses on this data. So the first one focused on the effect of just work hours on mental health. But there's a big challenge here, right? Because there's a reverse causality issue. So it might just be that being in better shape mentally, it gives you, more, encourages you or makes you more able to work more. So this is the advantage of this being a longitudinal study. We can get around this by examining the extent to which mental health changes as a function of your work hours. So we can look at those within-person changes over time. And this is something that's been advocated for when working with longitudinal data. So in this model, you don't need to worry about the equations, but the dependent variable is the change in mental health from one year to the next. And there are 2 key predictors. So the hours per week worked in the previous year and the change in hours per week worked from the previous to the current year. And then there's quadratic terms and a 2-way interaction just to make things fun and interesting. And what this analysis allows you to do is to create this sort of map. And the x-axis on this map is the hours per week worked in the prior year. The y-axis is the change in hours per week from the current to the prior year, from the prior to the current year, rather. And the color represents the change in mental health. So red is more favorable, blue is less favorable. And this white area is not really theoretically important. It's just these are observations that were impossible, because if you're working few enough hours, there's this limit to how much your hours could decrease, because you can't have negative hours per week. So the line here are situations where people's work hours increase. So above this line, below it is where people's work hours decrease. And so what you can see is that when people are working relatively few hours and their hours decrease to this bottom left region just beyond the white, they're, as you'd expect, not super chuffed about that. They experience a decrease in well-being. If they're working few hours and they have an increase in work hours, they're generally happier. But if they're working a lot of hours, they're less happy when they have an increase in work hours, but they're much happier when they have a decrease. And this is actually the happiest situation in this survey, is when people experience a decrease in work hours when they're already working a lot. So some preliminary evidence here that, as long as you're not working, as long as you're not underemployed, changes in your work hours, decreases in your work hours generally leads to increases in or more favorable changes in well-being. Actually, let me go back. So this makes sense, but the issue is that there's a number of reasons why your work hours could change. So some of them are good, some of them might be wanted, like you transition to retirement. So people might become semi-retired. Others might not be so good. So maybe you lose your job or you lose hours, or maybe you become physically or mentally unable to work as much. And so in this next analysis, what we did is we took into account the hours per week that people preferred to work. And there's some extra two-way and there's a three-way interaction as a result of that. But otherwise, the model is just the same. And you can do the same thing here. So here on this map, the x-axis is now the hours per week preferred in the prior year. The y-axis is the hours per week actually worked. And again, the color represents the change in mental health. So this diagonal represents people that work the number of hours that they want to work. Sometimes this is called a work hour match. And as you'd expect, and as is seen in the literature, people are generally happier when this is the case. When there's a work hour mismatch, when people are working more than they want to work, which is this top left region, people's well-being suffers. When in the bottom right region, when people are working less than they want to work. Let me just make sure I got that right. Mm-hmm. Yes, less than they want to work, well-being suffers as well. But what you can also see here is that it's not just about having that work hour match. It's not just about working the amount of hours that you want to work, because there's sort of a special well-being bonus when those hours are fewer. So in general, people are happier when they're working the hours that they want to work, but they're particularly happier when those hours are fewer. So when people are wanting to work fewer hours than they actually are able to work those. So, and in case you're interested, there's this three-way interaction, which makes sense. It's not particularly theoretically interesting, but it just for completeness, I've got it here. So there's an interaction with those two variables and the change in work hours. So basically, if your work hours decrease, you're going to be particularly upset in this bottom right region of this left panel, where you're already working fewer hours than you want. If your work hours increase, which is the right panel here, you're going to be particularly upset when the hours are already higher than you want. Not particularly theoretically interesting, but it's good as a sanity check. All right, so at IOP, I made a big song and dance about how we need to work fewer hours. We've had mounting evidence that we need, that it's even 4 days might be too much. Since then, I've done some thinking and some simulations, which I'm going to present, that basically undercut that. And it has to do with the modeling approach we use to analyze this sort of data. So this change score modeling approach, where you look at change in factor X, predicting change in factor Y. This is sort of regarded as one of the current best practices for analyzing longitudinal data. So the argument is that you need to model this phenomena, that dynamics and change over time, and the best way to do this is to look at whether a change in factor X, which in this case would be work hours, is followed by a change in factor Y. So in this case, it'd be mental health. There are two big problems with this approach to longitudinal data analysis. So one is that we have very strong assumptions about time lag. The time it takes factor X to produce a change in factor Y. So in this case, for work hours to produce a change in well-being or mental health. You have to specify a lag to run this analysis, like a lot of analysis. And we have virtually no theory to help us make a decision about what that time lag should be. In this case, it was just a year because that was the measurement interval. And that's almost always the case, where people just measure at whatever frequency, and the lag in the analysis is just the measurement frequency. But again, we have no theory to guide that decision. And it's almost definitely the case that the time it takes for factor X to produce a change in factor Y is different for different people and different jobs. And so when you're making these strong assumptions, you have issues. So for example, if for some people or for everyone, the time it takes for work hours to produce a change in well-being is 2 years or 3 years, then we're not going to detect that effect, or at least we're going to underestimate that effect. The other problem is that theoretically, there doesn't need to be a change in your work hours for you to experience a decline in mental health due to working too many hours. And so I'm going to take you through an example that's theoretically plausible, that just can't be assessed using current modeling approaches. So here's the example. So a person's working 60 hours a week over the course of some amount of time. It could be years, it could be months, doesn't really matter. The logic is the same. But we'll just call it years since that's the time frame we've been working with. And so over the first 5 years, mental health is stable. But at year 6, you see a mental health decline. No change in the environment, no change in the hours worked, no change in the demands. So why does this happen? Well, theoretically, this is perfectly reasonable that this would happen. So you'd assume that consistent with theory, there's some sort of latent stress process that accumulates in the background. So I call this accumulated exhaustion here, and this accumulated exhaustion has a tipping point. So before the tipping point is reached, this stress or this exhaustion is building, but it hasn't yet got to a point where it's producing any reportable or observable changes in mental health. And then once this tipping point is reached, you have a straw that broke the camel's back situation, and there's a sudden decline in mental health, again, even in the absence of any change in the stressor. So in this case, it's the hours worked per week. Now, the challenge is that this can't be captured using any current statistical modeling approaches because there is zero variance in the independent variable. Don't take my word for it. To illustrate, I actually did some simulations. So I simulated this with 1,000 rather fake participants. And I added within-person noise just to make things fun and interesting and more realistic. But the basic premise is the same. So work hours is stable at around 60 hours per week on average, even though there's some variance in the trajectory here. As a result of the variance in the hours per week trajectory, there's variances in accumulated exhaustion and mental health, but the mean effects are the same. And I did this 20 different times. So varying with each kind of simulated data set, I varied the time it takes to reach the tipping point. And that's represented by the different lines here. So on one extreme, this red line that's lower down, the participants reach the tipping point really quickly, generally before the second wave. And as a result, their mental health decline kind of straight away. And at the other extreme, people experience the tipping point later on. So some of them didn't even reach it at all. And so there was only a slight decline towards the end, and then everything in between. And on this simulated data, I ran a few different analyses. So these are analyses that are typically used and typically advocated for analyzing this type of longitudinal data. So the first analysis I ran was this change score analysis, where the DV was the change in mental health in 1 year, and the IV was the change in mental health in that same, so prior to current year. And on the x-axis here is the time to tipping point. So it's the different simulated data sets. So the left part is where people reach the tipping point very quickly. The right part is where people reach tipping point only towards the end of this process. And the y-axis is the estimated effect of the IV on the DV in each of these different analyses. And the red is the true effect. So because we simulated the data, we know what the true effect is. It was minus 0.003 in this case, just because that made the numbers work. And so we can use that as a benchmark to see how accurately this analysis captures the true effect. Now, remember, the true effect doesn't reveal itself until after the tipping point is reached, but once it does, it's just a linear decline at that rate. So it's a pretty simple simulation. So the first graph is showing that basically this change score analysis completely misses any true effect. Again, because there's no systematic change in hours per week, so you wouldn't necessarily expect there to be a relationship between that and the change in mental health. The second analysis I ran was just swapping the IV. So instead of it being the change in the hours per week, it was just the hours per week worked in the prior year. And this one actually did a pretty good job because the nature of the cumulative effect in this simulation meant that it was the hours per week rather than the change in the hours per week that was more linear related to the change in mental health. Caveat, though, is that this only works when everything's completely linear. When the effect of hours per week on stress is linear, and when the effect of stress on mental health is linear, and when there's no recency effect. So when, for example, you can create simulations where it's the more recent years that affect stress more strongly than previous years. This wasn't the case in this simulation. And so because it was so simple, this did really well. When you try and make things more complicated, adding nonlinearities, adding recency effects, this also kind of goes away. And even in this case, though, even in this simple case, you lose the effect after 10 time lags. So longer term effects aren't really able to be picked up with this analysis. I use another approach which is often advocated or often used, where you're regressing the person mean-centered mental health variable, the person mean-centered DV on the person mean-centered IV. The logic here is you're partialing out any between-person variance, and so just looking at the within-person variance. This actually drastically overestimated the effect, and there's a reason for that, which will become clear in a minute. And the reason for that, well, basically is that in this first set of analyses, I did not control for prior levels of mental health. And so when you're not controlling for prior levels of mental health, in this particular analysis, the effect is exacerbated. When you control for prior levels of mental health, which is what I did in these bottom set of analyses, same analysis, except you just add the extra predictor, you're now missing the effect in pretty much all of the analyses, or at least underestimating the effect considerably. And again, this is just a really simple example. So when you add more realism, more nonlinearities, recency effects, all these things that are almost theoretically definitely exist, things break down even more. So this is kind of my last slide. So this is very much a work in progress. I'm literally just running these analyses this week for a grant application that we're working on. But the main takeaway at this point is we probably don't know as much as we think we know about the relationship between work hours and mental health. If anything, the effects are probably stronger than previous research has revealed. Remember, in most cases, the analyses were underestimating the true effect. But the issue of time lag, it really hides a lot of the dynamics that are happening. And so we need better tools. And so, I said earlier in the presentation that this relationship is hard to study. Well, my updated assessment, now having done these analyses and thought about this stuff a little bit longer, is that this relationship is really, really hard to study, especially when you're not using the right tools. And so, my argument, which is going to surprise exactly zero of you, is that we need computational modeling here. So conventional statistics are just not going to cut it. We need to develop a model that directly represents the process by which stress accumulates and the tipping point is reached. And then we can use that to analyze this sort of data. And so, with that sort of model, we can answer questions like, how long does it actually take for people to reach that tipping point? And are there individual differences or differences between jobs and how long that it takes to reach that tipping point? Or differences in what happens after that tipping point is reached. Like maybe people, certain people in certain jobs don't have as severe a decline and some people drop off quite rapidly. Or, other questions like, does everyone have a tipping point? Or is the relationship more linear for certain people and why that might be? This sort of model would also help overcome challenges with existing approaches like the presence of missing data. So in these sorts of studies, you get a lot of missing data and it's never random. So a lot of times if someone is having a particularly, rough year, they won't do the survey. And so dealing with that missing data is important because it's not random. Uneven measurement intervals. These are all sort of things that are problematic for conventional approaches, not a problem for computational modeling. So the idea is you could have a better representation of the process and be able to utilize more data and able to analyze that process. Then ultimately, if we can develop and validate a computational model like this, we can use it for prediction. So we can predict or make forecasts about how the dynamics of the work hours mental health relationship plays out in different situations. So for different people and different jobs, and then we can use that to ultimately inform, better inform policy. So I'm basically just giving the elevator pitch for my grant at the moment, but I've started kind of working on an initial version of the model. I was hoping to have some insights to present, but it's not quite there yet. It's still early days, so this is where I'm up to at the moment. So watch this space. So that's it.